Hey everyone! In this lesson we're going to review multiplication and division involving decimals. Now I know this isn't a particularly hard concept, so we're just going to do a couple of examples of each. This might be a somewhat short lesson, but if you find that you're going through this lesson and something's not making sense, then what we can try is go back to last year's videos, which I'm going to show you in just a second. So here are last year's videos on this topic. So we've got a couple of videos on multiplication and division working with decimals. As you can see, this is a little bit over an hour and a half's worth of videos. It's all actually quite close to 2 hours worth of just working through these types of problems. So if there's something here that's not making sense in this video, we're just going to do a couple of quick examples of multiplication, and then division was a real pain to make in PowerPoint, so I'm just going to talk about it but not really go through an example, especially because I've already made videos on this subject. So if you go into last year's videos, basically if you scroll a long way down, or if you look in the Flamingoes Math 2019-2020 playlist, then you will find these videos and a whole bunch more in there. It's the playlist with 63 videos in it, I think. So if you're not able to find it by the name, then look for the biggest playlist that's on there, and it's lessons 6, 7, and 8 in there. So we'll begin with multiplication involving decimals. The way this works is basically you can go through the problem without really worrying about the decimal points itself while you're actually going through the math of it, and then just throw in the decimal point at the end. So if you read the second point that I've written there, it says add in a decimal point at the end such that the number of digits after the decimal point in your answer is the same as the sum of the number of digits after the decimal point in the two factors. So there's a lot to unpack there, so let's do that. Let's begin with, it says the number of digits, so right here, the number of digits after the decimal point in your answer. So in order to actually put this into practice, we're going to have to get to an answer first. And the number of digits that we have after the decimal point in our final answer needs to be the same as the sum of the number of digits after the decimal point in the two factors combined. So basically, if we look at this first problem right here, we've got 2 digits after the decimal in the first line, and we've got 1 digit after the decimal in the second line. So that's a total, that's a sum of 3 digits after the decimal point in these two factors. Factors are the things that you're multiplying together. So we've got a sum total of 3 digits after the decimal point in those two factors combined. So when we work through the multiplication problem, we're actually going to pretend that these decimal points don't exist, and then we're going to throw in the decimal points at the very end. So basically it's going to look like this. So here it's the same numbers, it's still 4, 2, 5, and we're still multiplying it by a 1 and a 2 down there, but what I've done is I've gotten rid of the decimal points that we had in here and in here. So those decimal points no longer exist, and now we're going to work through the problem as though it was just 425 times 12 instead of 4.25 times 1.2. So if we do that, this is a bit of a review of long multiplication as well, but if you need more practice with that, there's stuff on that from last year as well. So we'll begin with the number in the ones column of the second factor, and we'll multiply it by each of the digits in the top row from right to left. So we start off with taking this 2, multiplying it by that 5, we get 10. So we put the 0 down here, and we carry a 1. Good, now we do 2 times 2, that's 4. 4 plus 1, that's 5. So we'll get a 5 down here. like so. And then we do 2 times 4, that's 8. And that's that for the first row. Now we move down a row before we take care of this number 1. I'm going to do it in a different color. So we did all the first stuff in red, so we're going to work with this 1 in green. And before we start working with the 1, we need to put in a little placeholder. Now you can put in a 0 if you want as your placeholder. I like to put an X so that I don't confuse it with a 0 from the answer to a multiplication problem. So I just put in an X that really means a 0. So you could put a 0, you can put an X, you can put a 0 with an X inside of it. Something that tells you that it's a placeholder and not a 0 from one of your answers. Because if you look in a different color, this 0 right here came from actually doing the multiplication between 2 and 5. But if this happened an extra row down, then we might lose track of, well, is that our placeholder or is it the result of our multiplication problem? And when you're multiplying really, really big numbers together in this manner, you can end up with a whole bunch of zeros towards the right end of each row as you build subsequent rows, going down the side. For multiplying really, really big numbers, you'll get a whole bunch of placeholders in those rows down there. So it's really important that you differentiate them from your actual answer by putting in something that means 0 but doesn't look the same as any other 0. So I'm going to use X as my placeholder there. And now we start the multiplication process with this 1. So we multiply this 1 by each of those things up there. We can get rid of that 1 that we carried. Just scratch that out. So then we do 1 times 5 is 5. And 1 times 2 is 2. And 1 times 4 is 4. Easy enough. Okay, so basically, if you just look at the row by itself, we multiplied 1 by essentially 425, and we got 425 down here. So that part makes sense if we're ignoring the placeholder. And in the first row, we were basically multiplying 425 by 2, which gave us 850. So we can be quite confident then that we've done this right so far. Now in the second row of factors right here, we've run out of numbers. We've done everything that we need to with this 2, and we've done everything that we need to with this 1. So now we can just go ahead and do some addition for our result. So we're going to add those. It's important to make sure everything is lined up, which we've done a decent job of here. So we add those up. In the first column, the rightmost column, we get 0 plus 0 is 0. In the second column, we get 5 plus 5 is 10. So we get a 0 here as well, but we carry the 1. Now 8 plus 2 is 10, plus 1 is 11, so we put a 1 down here and carry the other 1. And then 4 plus 1 is 5. Now we're nearly done, but remember that the original question was this one over here was our original question. So if I just get rid of the little red markings in there, our original question was 4.25 times 1.2. So basically that's 4 and a little bit times 1 and a little bit. So our answer should be a little bit bigger than 4, and right now our answer is looking like 5,100. So the reason for that is that we still have to do that last step where we go back to this point over here, which says that the number of decimal points in your answer, so the number of digits after the decimal point in your answer is the same as the sum of the number of digits after the decimal point in the two factors. So if we look at the two factors, that's these two numbers over here, the 4.25 has 2 digits after the decimal point, the 2 and the 5. And the second factor, the 1.2, has 1 digit after the decimal point. So we don't care what the digits themselves are, we just care how many there are. So in total we have 3 digits after the decimal point in these two factors. So that means in our answer over here, there needs to be we need to make sure that we have the same number of digits after the decimal point. So we've got a 4-digit number here. We need to make sure that 3 of the digits are after the decimal point, so that means it has to slot in right there. And that tells us that our final answer is 5.1. And you can ignore those zeros at the end, so then your final answer is 5.1. That's a really small decimal point. There we go, 5.1. That's our final answer for this problem. And that's basically the way that multiplication with decimals works. We're going to do one more example just for fun, and then we'll discuss the division problem. But it was a little bit hard to actually create the problem the way I wanted to. So I'm just going to talk about it in an example that I stole off Google. But of course, before we do that, we're going to go through this second example of multiplication. The rules that I've written up here haven't changed at all, so we're just going to follow the same process by working through this example down here. So, as it says in this first bullet point, disregard the decimals while doing the multiplication problem. So that means that our multiplication problem turns into this. So I've left a 0 there just so that you can see that I have taken the decimal point out and haven't done anything else. But if we've got 0, 5 and it just means 5, then that means we could really just get rid of this 0 entirely, right? It's going to take me a second, but you get the idea. So basically we're getting rid of this 0 and we're just doing 735 times 5, and then we can put in the decimal points back in at the end once we've worked through the rest of it. So that should be good enough for the point that we're trying to get across here. So let's go ahead and do that multiplication problem. So we begin with, well, we've only got the 1 digit in this second row, so we're just going to multiply it by each of the digits in the top row from right to left. So we start off with 5 times 5, that's 25. So we get a 5 down here. Carry the 2. 5 times 3 is 15, plus 2 is 17. Carry the 1, and ignore that dot there and that dot there. Okay, now back to black. So last step is 5 times 7, that's 35, plus 1, that's 36, so we can write that in. Right, ooh, that's terrible, that's terrible. We're trying to get 36, so I need a proper-ish looking 3. There's a 3, there's a 6, there's our 36. Okay, so we are almost done the problem now. The issue here is that we are missing the decimal point, because basically the question was this thing over here, 7.35 times 0.5, or that's the same thing as 7.35, oh, sorry for my writing, 7.35 divided by 2. That's the same thing, right? Multiplying by 0.5, that's the same thing as multiplying by a half, or basically dividing by 2. So basically we should be getting a number that's definitely smaller than 7, right? And if we ignore the 0.35 at the end, and we just sort of forget about that for a second, then it's basically 7 divided by 2, which should be 3.5, and then a little bit of change because we ignored this 0.35. When we're just ballparking our answer, 7 divided by 2 is 3.5, but we know it's going to be a little bit bigger than that because we weren't working with 7, we're working with something slightly bigger than 7. So when we look over at our answer, before we go through the process of trying to count how many digits we need to worry about here, we can just sort of use logic to figure out what the answer should be based on the fact that we know it's pretty much 7 divided by 2. But if we go about it the decimal point way, then we've got 1, 2, 3 digits after the decimal point in our two factors. Once again, we don't care what the digits are, we just care that there are 3 of them, and that tells us that we need to make sure we have 3 digits after the decimal point over here. So then we slot in our decimal point right there and get an answer of 3.6. Whoa, goodness. 3.675. And that's the answer to this multiplication problem. And if you wanted to check your answer, you could always take this answer that we just got, this 3.675, and multiply it by 2, because that's the opposite of what the question was asking us. Multiply it by 2 and see if you get 7.35 as your final answer. So I'll leave that for you guys to try if you wish, but we can be fairly confident that this is the right answer. So when it comes to division involving decimals, the important thing that you need to remember, I'm not going to work through a full example here just because it's really hard to write with this touchpad. But basically what you want to do is, if you've got a number like, we're not going to work through this problem, so it's not necessarily going to be a nice clean answer, but let's say you had 26.408, okay, and you were dividing that by let's keep it simple. I was going to make this number, this divisor, a decimal, but let's just say you're dividing it by 2. The thing you need to remember is that when you're going through the process of long division, then you need to line up the decimal that's down here in your dividend. You need to line it straight up to where you're going to write your quotient, and the decimal point in your quotient, so that's this this one with the green arrow, needs to be directly above the one that's down here. Okay, so that's really all that you need to remember. If you remember the rest of how long division works, then you're all set. If you would like a refresher on long division, just because this PowerPoint thing makes it really hard to write this, and I can't really point on the screen without making markings on the screen with the little pointer that I've got here. I'm going to ask that if you need help with long division, that first you go to last year's videos. So the videos I showed you at the beginning are lessons 6, 7, and 8, and that's working with multiplication and division with decimals, but I think it was like lessons maybe 3 and 4 possibly, or 4 and 5, something like that, are working with just long division with whole numbers. So if you would like a review of long division in general, then go back and check those first couple of videos, lesson 3 or 4, or 4 and 5, or something like that. And if you would like a more thorough review of long division involving decimals, then check out videos 6, 7, and 8 from last year. But basically, if you're comfortable with the idea of long division, then the process for long division with decimals is exactly the same. In that when you're working through the problem, you can ignore the decimal entirely. So you can forget that this exists. And you can, to be honest, while you're working through the problem, you can forget that that one exists as well. And then when you get your final answer, so for this one, that would be 1, 3, 2, 0, 4. Then just make sure that at the end of the problem that you stick that decimal back in there. If you ignored it while working through the entire problem, then make sure you stick that decimal point back in there. Otherwise, what you can do at the start is you can line up the decimals like I was saying before, that you've lined this straight up, put the decimal point in there, and then forget about it. For the rest of the problem, just forget that the decimal points exist, and you can work through the problem that way. So here's just an example of a long division question. Now, just for terminology's sake, just a reminder that this number right here is the dividend, so that's the number that you're starting with. The divisor is, let me see if I can draw this all the way around, down and around, is this one right here is your divisor, so that's the number that you're dividing by, and then your quotient is the final answer that you get. So your quotient is that number up top. So if you go through the process of long division here, you'll notice, I want you guys to try this as a bit of an exercise. Try doing this question without the decimals, and then throw in the decimal points in the appropriate locations, and you'll hopefully see that that it works. So just a super quick rundown of how this works. You ask yourself, how many times does this 5 go into this 2? And we get that it doesn't go into 2 any number of times, it goes in 0 times. So that's why we get this 0 up here. After that, we have to ask ourselves, what is 5 times 0? Well, 5 times 0 is 0. So hang on, 5 times 0. This 5 right here is coming from our divisor, and this 0 right here is coming from that 0 up top that we just wrote down. So 5 times 0 equals 0. That gives us this 0 right here. So that means that we're still left with 2. So right, 2 minus 0 is 2. Then we bring down this 8. So now this becomes a 28 right here. And then we ask ourselves, how many times does 5 go into 28? And we get that it goes into 28 5 times. So we write that 5 up there. We do the multiplication. 5 times 5 equals 25. That's why we have this 25 in here. We do that subtraction. 28 minus 25 is 3. So that's where that 3 is. Then we bring the 7 down. We repeat the process. How many times does 5 go into 37? Well, it goes into 37 7 times, so that's where we get this 7 right up here. So we do 5 times 7. 5 times 7 equals 35. That's this 35 in here. We do that subtraction. We get 37 minus 35 is 2. And we want to keep going until this final answer is a 0. So because we had a 2 at the beginning, and then we had a 3, and now we have a 2 again, that means we still have to keep going until either we notice a pattern or we get a 0 at the end. So then, as you can see, because the whole problem's been solved, the last step is you bring down that this 0. So actually the way it looks, the way they've made this problem, is that the question was originally 2.87 divided by 5, and they didn't have the 0 on the end. But the problem is that if you've got this 2 left over, then you need to keep adding something so that you can bring some number down. You need to add something on the end there so that you can bring a number down and work through the rest of the problem. Now the trick is that 2.87 is the same thing as 2.870, and that's the same thing as 2.8700, and that's the same thing as 2.87000. So you can add in as many zeros as you need to here to either get to a final answer or to notice a pattern going on with the numbers that you're getting. But so what they've done here is they've added in this 0 because it doesn't change the value, right? 2.87 is the same as 2.870. So you can bring that 0 down. Then you ask yourselves, how many times does 5 go into 20? That's 4 times. That's where this 4 comes from. You do the subtraction. 20 minus the thing that you're subtracting in there comes from 5 times 4. 5 times 4 is 20. That's where this one comes from. And then we do that subtraction, we get 0 left over, and that means that we're done the problem. So that's the way long division works. I was going to write one out and sort of work through it step by step with you, but when I was trying to make it in PowerPoint or in Microsoft Word or something, getting this shape was just causing me too much trouble, and I was in the middle of working on some other stuff at the same time, so I thought, you know what, we're just going to work through an example right off Google and we'll sort of walk through it step by step. But that's the way that long division works, and then you can see that going through that, I completely ignored the decimal point during that process. So the way I just went about it, we would have had 0.574 up there. Now we just remind ourselves that we have a decimal point here that needs to line up directly above, so we get that decimal point right in there. And so that gives us our answer of 0.574 for this question. So just a little note to end off this lesson. We're just going to talk briefly about a couple of tricks of the trade when you're multiplying and dividing by powers of 10. So powers of 10 meaning something that if you multiplied or divided by 10 a whole bunch of times, the answer that you get is some power of 10. So right now we're working with multiplying by powers of 10. So let's start by talking about if you multiply by 10 or something that's a factor of 10 bigger. So 10, 100, 1,000, 10,000, 100,000, a million. So basically just keep adding zeros. It's some power of 10. Anytime that you're multiplying a number like that, a number that's got a 1 and then just a bunch of zeros after it, a 1 and then a bunch of zeros after it, then without actually changing the digits themselves in your problem, so let's say you're doing like 7.104 times 100, let's say, okay, times 100, then all you have to do is take this decimal point and move it towards the right without changing the digits. Now, how many steps do we move it to the right? Well, that's what you get from down here. The number of spaces that you're moving the decimal to either side. So right now we're working with moving it to the right. So the number of steps that we have to move it over is the same as the number of zeros in the number that you multiplied by. So we multiplied by 100. 100 has 2 zeros, right? So that means that we move it over 2 spaces. So move it over 2 spaces from where it is right here, 7.104. It'll move over to here. So when you do the multiplication, 7.104 times 100, you'll get 710 all before the decimal point. Then you'll have your decimal point and then the 4 at the end. So you get 710.4. So you don't have to change the digits, you're just moving the decimal point. If you're multiplying by basically the opposite, so if you're multiplying instead of 10, 100, 1,000, you're multiplying by a tenth, a hundredth, a thousandth, so 0.1, 0.01, or 0.001, and so on, then you move the decimal point towards the left instead. So that's just the sort of the trick to it, is if you're multiplying by 10 or bigger, then you're moving the decimal point to the right, and if you're multiplying by 0.1 or smaller, so a tenth or smaller, then you move the decimal point to the left. The same trick applies for moving the decimal to the left, in that you just need to count the number of zeros in the thing that you multiplied by. So for instance, if we were multiplying by this, we just need to count the number of zeros in this number, and that'll tell us how many spaces we need to move the decimal point. One word of warning that you need to be careful of is that if you're working with multiplying by one of these small numbers, so 0 point something something something, in order for this trick to work, the equal to number of zeros thing, in order for that trick to work, you need to include this 0 that sits before the decimal point, this 0 before the decimal point, this 0 before the decimal point. Those need to be there in order for the trick to work. It's not wrong to write the number as just 0.1, but then this trick doesn't work. You need to write it as 0.1 in order to use the trick with the zeros for this multiplying by powers of 10. And just to wrap up, we'll talk about dividing by powers of 10. So it's almost exactly the same idea, except the directions are flipped. So for multiplication, when we were multiplying by big numbers, so 10, 100, 1,000, we move to the right. With division, when you're dividing by 10 or something bigger, you move to the left. And with multiplication, when we were multiplying by the really small things, so multiplying by a tenth, 0.1, a hundredth, 0.01, and so on, then we were moving to the left, and in division, we're moving to the right. So it's exactly the same idea if you're seeing multiplication or division by anything that's involving these kinds of numbers, or these kinds of numbers, then you can just use this trick and you don't actually have to do any math. It's just a matter of moving the decimal point and making sure that you move it the right number of spaces. The same trick applies here, that if you are using the 0 trick and you're dividing by one of the really small numbers, 0.1, 0.01, etc., you need to have that 0 that's in front. So you could write it as just 0.1 if you want, but then the trick of counting the zeros doesn't work. Because, for example, if you were trying to divide by 0.1 and you just wrote it as dividing by 0.1, you're trying to count the zeros and there are no zeros, so you just wouldn't move the decimal. So it doesn't work out that way. You need to include that decimal there so that it allows you to actually move the decimal at least one space. So hopefully that makes sense. This is the end of this lesson. I did go through some of the math maybe a little bit quickly, but I went about it more thoroughly than I was expecting to while I was making the lesson. So hopefully this is clear. If it's not, let me know. But please, 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 if it's not clear, check out last year's videos first, because I spent almost 2 hours on those lessons and they are there for you guys to look at now if you need them for review. But if it's still not making sense after that, let me know and we can work something out. Other than that, if you don't have any questions, I will see you in the next video. Have a good one.